Good morning, students. So today we are going to continue few questions from yesterday's class, that is mechanical properties of fluids. Okay, so ಕೆಲವೊಂದು questions ಅನ್ನ ನೋಡೋಣ. ನಿನ್ನೆ ಸ್ವಲ್ಪ ಕಡಿಮೆ questions ಅನ್ನ ಕವರ್ ಮಾಡಿದ್ವಿ ನಾವು. ಈಗ ಸ್ವಲ್ಪ questions ಅನ್ನ ಕವರ್ ಮಾಡಿ then we will proceed to the next concept, that is thermal properties of matter. Okay, so today we are going to see the next question, that is two water pipes of diameter. I hope the screen is visible. PPT ಕಾಣ್ತಾ ಇದೆ ಅಲ್ಲ? Yes. Okay, two water pipes of diameters 2 centimeter and 4 centimeter are connected with the main supply line. The velocity of flow of water in the pipe of 2 centimeter diameter is. So this question edra mele based ide heli? This question is based on equation of continuity. Equation of continuity mele ee question depend agide illi, aita? So here the two pipes, water pipes, they are taking of the diameter 2 centimeter and 4 centimeter. So ಎರಡು pipe ದು diameter ಒಂದ್ರದ್ದು 2 centimeter ಇದ್ರೆ ಮತ್ತೊಂದು 4 centimeter ಇದೆ. They are connected to the main supply. So ಒಂದು common supply ಗೆ ಅದು connect ಆಗಿದೆ. The velocity of flow of water in the pipe of 2 centimeter diameter is. So ಇಲ್ಲಿ ನಮಗೆ ಏನು ಬೇಕಾಗಿದೆ, 2 centimeter ಏನು pipe ಇದೆ ಅದರಲ್ಲಿ diameter ಎಷ್ಟಿದೆ ಅಂತ ನಾವು ಇಲ್ಲಿ calculate ಮಾಡಬೇಕಾಗಿದೆ. Okay, so how we can do this one? So based on equation of continuity, if you know, you can try, or else I'll tell you what is that given is, that is, I'll take that diameter is 2 centimeters. So pipe I'll consider it as A. One more pipe I'll consider it as B. A pipe ಮತ್ತೆ B pipe ಅಂತ consider ಮಾಡ್ತೀನಿ. ಅವರು diameter ಕೊಟ್ಟಿದ್ದಾರೆ, ಆಯ್ತಾ? ನನಗೆ ಇಲ್ಲಿ ರೇಡಿಯಸ್ ಬೇಕು. ರೇಡಿಯಸ್ ಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕಾಗುತ್ತೆ, ಡಿವೈಡೆಡ್ ಬೈ 2 ಮಾಡ್ಬೇಕಾಗುತ್ತೆ, ಹೌದಾ? ಸೊ 2 centimeter divided by 2 ಅಂತ ಅಂದ್ರೆ RA will be 1 centimeter. 4 centimeter divided by 2 centimeter ಅಂತ ಅಂದ್ರೆ 2 ಅಂತ ಅಂದ್ರೆ that is 2 centimeter. I hope it is clear. Diameter ಕೊಟ್ಟಿದ್ದಾರೆ 2 ಮತ್ತೆ 4 ಅಂತ, ನಮಗೆ ರೇಡಿಯಸ್ ಬೇಕು, that is divided by 2 ಮಾಡ್ಬೇಕಾಗುತ್ತೆ. Therefore the radius of A pipe will be 1, the radius of B pipe will be 2. ಗೊತ್ತಾಯ್ತಾ? Then next, it is based on the equation of continuity ಅಂತಂದ್ರೆ AB is equal to constant. It is based on equation of continuity. So this equation can be written as, ನಾವು ಇದನ್ನ ಯಾವ ರೀತಿಯಾಗಿ ಬರಿಬಹುದು? For A, the velocity of A divided by the velocity of B is equal to, so it is constant divided by area, ಹೌದಾ? ಸೊ ಇದೇನಾಗುತ್ತೆ, ಏರಿಯಾ ಮತ್ತೆ ವೆಲಾಸಿಟಿ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ. Therefore when it is inversely proportional, can I write it like this, that is VA by VB is equal to the area of B divided by the area of A. I hope it is clear. Velocity and area are inversely proportional. So where velocity of A is equal to 1 by velocity of that is area of A, we are taking the equation in this form. So substitute. It is a pipe. So pipe anta andre the area of cross section of the pipe is given by pi r square. ಹೌದಾ? pi r square. ಇದು B ಇರೋದ್ರಿಂದ ಪೈಪ್ ನಾನು ಇಲ್ಲಿ B ಅಂತ ತಗೋತೀನಿ, ಡಿವೈಡೆಡ್ ಬೈ pi r a square. pi cancel ಆಗುತ್ತೆ. rb by ra. rb is how much? It is 2. ra is how much? It is 1. So 2 by 1 square, this is nothing but 4. So here see options ಏನಂತ ಕೊಡ್ತಿದ್ದಾರೆ, that is option A is 4 times that of in the other pipe, 1 by 4 times, 2 times, 1 by 2 times. So our B pipe radius will be, or the A pipe radius will be VA is equal to 4 times of that of the B. I hope it is clear to you. So therefore the equation 1, yes, so it's correct, it is, that is first one is right option. I hope it is clear to everyone. It is based on equation of continuity. Let us go to the next question. Yes, the next question is, okay, you can see this, an incompressible liquid. So here we have the incompressible liquid flows through a horizontal pipe, tube, as shown in the figure. So ನೀವು ಇಲ್ಲಿ figure ನೋಡಿದ್ರೆ from A point, ಅಂದ್ರೆ ಒಂದು A point ಇಂದ ಏನಾಗ್ತಾ ಇದೆ, it is getting split it into 2 points here. ಹೌದಾ? Then the velocity of V of the fluid. So V1 ನೀವು figure ಅಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ figure ಅಲ್ಲಿ ಅವರು ಡಾಟಾ ಕೊಟ್ಟಿದ್ದಾರೆ, ಏನೇನು ಕೊಡ್ಬೇಕಾಗಿದೆ ಅದನ್ನೆಲ್ಲ. At A point the velocity is 3 meter per second. At ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ, that is here. ಆಯ್ತಾ? ಇಲ್ಲಿ the velocity is 1.5 meter per second, and here you can see V. ಇಲ್ಲಿ ನೀವು V value ಅನ್ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೇಕಂತ ಅವರು ಕೇಳ್ತಿದ್ದಾರೆ. Okay, so therefore the solution can be given as then the velocity of V is given by, so I'll just take it as whatever the velocities are there, that is at A. Okay, so the velocity A is equal to V1 plus V2. So it is again based on the equation of continuity itself. It is based on the equation of continuity. So therefore, so instead of taking it as velocity, I'll just take the equation of continuity. ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡೋಣ. ಏನ್ ಕನ್ಸಿಡರೇಷನ್ ಮಾಡೋಣ ಅಂತಂದ್ರೆ, ನಮ್ದೇನ್ ಇಕ್ವೇಶನ್ ಆಫ್ ಕಂಟಿನ್ಯೂಟಿ ಇದೆ, ದಟ್ ಇಸ್ AB is equal to ಕಾನ್ಸ್ಟೆಂಟ್ ಅಂತಿದೆ ಅಲ್ಲ, ಆ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ನಾನು ಇಲ್ಲಿ K ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಆಯ್ತಾ? ಸೊ therefore K is equal to, K ಅಂತಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಅದು, ಅದು ಯಾವ ಕಡೆಯಿಂದ ವಾಟರ್ ಫ್ಲೋ ಆಗ್ತಾ ಇದೆಯಲ್ಲ ಆ ಪಾಯಿಂಟ್ ಅದು K ಅಂತ ಆಗತ್ತೆ, is equal to K1 plus K2. Right? So here at this point, ಈ ಕಡೆ ಇಲ್ಲಿ ಏರಿಯಾ ಏನಂತ ಇದೆ, the area is A. ಹೌದಾ? area is A. Velocity ಏನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, the velocity is given as 3. So it is 3A is equal to, so K1 ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ನೋಡಿ, the velocity is 1.5 and the area is 1 plus K2 ಅಂದ್ರೆ ಕೆಳಗಡೆ ಎಷ್ಟಿದೆ ನೋಡಿ, that is it is again 1.5 into A into V, because we don't know the value of V ಅನ್ನೇ ನಾವು ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿದೆ. So 3A minus 1.5A, that is nothing but 1.5A. ಹೌದಾ? which is equal to 1.5 AV. Right? So 1.5 will get cancelled, A will get cancelled, therefore V is equal to how much it is? 1. V is equal to, it is 1. So therefore option C is the right option. Yes, Harshita, option C is the right option here. So students, take along with me only the solution so that we can cover more questions. Aita? We will go to the next question. Yes, summary. Next question. Nodi, that is water enters through end A with speed V1. Water enters through end A with speed A1, then and leaves through end B with speed V2 of a cylindrical tube. ನೀವು ಒಂದು cylindrical tube ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, for example, if you want diagram ತಗೊಳ್ಳೋಣ ಇಲ್ಲಿ. That is, if you consider one cylindrical tube. So for this cylindrical tube, water is entering through A with a speed of V1, and through A B it is leaving this through the velocity of V2, V1 matte V2. The tube is always completely filled with water. In case one, tube is horizontal, and in case two, the tube it is vertical. It is vertical end with end A upwards and end B downwards. ಹೌದಾ? And in case 3 ಅಲ್ಲಿ ಏನಾಗ್ತಿದೆ, B is at the top. So 3 cases they have given. So the velocity at A is V1, the velocity at B is V2. ಒಂದು case 1 ಅಲ್ಲಿ ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ, it is horizontal. Case 2 ಅಲ್ಲಿ ಏನ್ ಹೇಳ್ತಿದ್ದಾರೆ, A is on the top. Case 3 ಅಲ್ಲಿ B is on the top vertically. ಆಯ್ತಾ? Then upwards we have V1 is equal to V2 for. So V1 is equal to V2 ಯಾವ್ದ್ರಲ್ಲಿ ಸೇಮ್ ಆಗುತ್ತೆ ಹೇಳಿ? Can you guess? Case 1, case 2, case 3, case 4. ಎಲ್ಲದರಲ್ಲೂ ಸೇಮ್ ಆಗತ್ತೆ ಅಥವಾ ಯಾವ್ದಾದ್ರು ಕೇಸ್ ಅಲ್ಲಿ ಚೇಂಜ್ ಆಗತ್ತೆ? It is again based on equation of continuity. Yes. See the equation of continuity. Anybody knows answer? Question artha aitalla. That is, we have the pipe A and B with velocity V1 and V2. ನಾವು ಅದನ್ನ ಹಾರಿಜಾಂಟಲ್ ಆಗಿ ಇಡ್ತಾ ಇದೀವಿ, ಈ ತರ ಒಂದ್ ಸೈಡ್ ಮತ್ತೊಂದ್ ಸೈಡ್ ಈ ತರ ಇಡ್ತಾ ಇದೀವಿ. ಅವಾಗ A ಸರ್ಫೇಸ್ ಮೇಲ್ಗಡೆ ಬರುತ್ತೆ, ಮತ್ತೊಂದ್ ಕೇಸ್ ಅಲ್ಲಿ B ಸರ್ಫೇಸ್ ಮೇಲ್ಗಡೆ ಬರುತ್ತೆ. It is option D. ಯಾಕೆ ಹೇಳಿ? ನಮ್ದು ಇಕ್ವೇಶನ್ ಏನಿದೆ, ಇಕ್ವೇಶನ್ ಆಫ್ ಕಂಟಿನ್ಯೂಟಿ ಇಸ್ AV is equal to constant ಅಂತ ಇದೆ. AV is equal to constant. It is not depending on the position how you are keeping your pipe. ಆಯ್ತಾ? ಸೊ ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿಲ್ಲ. Therefore, in each case V1 is equal to V2. Why? Because it is of uniform area. ನಮ್ದು AV is equal to constant ಅಂತ ಇರೋದ್ರಿಂದ in each case V1 is equal to it is V2. Yes, very good students. So we will go to the next question. Yes, the next question is water is moving with a speed of, water is moving with a speed of, that is 5.18 meter per second through a pipe with a cross sectional area of 4.2 centimeter square. So speed is given, area is given. The water gradually descends 9.6 meter as the pipe increase in area to 7.6 centimeter square. So area increase ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ. The speed of flow at the lower level is, the speed of option D 2.86. Yes, it is right. 2.86 is right. Again, equation of continuity use ಮಾಡಿ. Can you calculate this, students? So use the equation as A1 V1 is equal to A2 V2. ನೀವೇ ಟ್ರೈ ಮಾಡಿ, ನಾನು ಇಲ್ಲಿ ನಿಮಗೆ ಹಿಂಟ್ ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಇಟ್ ಇಸ್ ಗಿವನ್ ಬೈ A1 V1 is equal to A2 V2. ಇಲ್ಲಿ ನೋಡಿ, ಸ್ಪೀಡ್ V1 ಕೊಟ್ಟಿದ್ದಾರೆ, ದಟ್ ಇಸ್ 5.18. ದೆನ್ ಇದ್ರ ಏರಿಯಾ ಇದೆ 4.2 ಅಂತ. ದೆನ್ ಏರಿಯಾ A2 ಇದೆ 7.6 ಅಂತ. ನಮ್ಗೆ ಬರೀ V2 ಬೇಕಾಗಿದೆ ಇಲ್ಲಿ. So you can substitute and you can calculate this. You will get the option D. You will get the option D. Okay, so please try this one yourself. We will go to the next question. Yes, the velocity of kerosene oil in a horizontal pipe is 5 meter per second. 5 meter per second. Acceleration due to gravity is 10 meter per second square. Then the velocity head of oil will be. So velocity head of oil. Velocity head anta andre idu namge illi ಒಂದು ಹೊಸ ಫಾರ್ಮುಲಾ ಬರುತ್ತೆ. The velocity head will be. It is given by, you can take the formula, that is V square. So option A, yes, it is option A, Harshita. Yes, it is correct. So students ನೋಡಿ ಇಲ್ಲಿ ಯಾವ ತರ ಬರುತ್ತೆ ನೋಡಿ equation. The velocity of kerosene head is given by V square upon 2G. So this is the expression here. V value is given, that is 5. G value is 10, that is 25 upon 10 into 2 is, that is 20. So if you simplify this, you will get it as 1.25 meter. Aita? It is 1.25 meter. So option A is correct here. Yes. Remaining students, let us go to the next question. So here you can see this. In the following figure is shown the flow of liquid through a horizontal pipe. 3 tubes A, B and C are connected. A, B and C are connected to the pipe. ನೀವು ಇಲ್ಲಿ ನೋಡಬಹುದು ಫಿಗರ್ ಅಲ್ಲಿ A, B, C ಮೂರು ಕೂಡ ಒಂದಕ್ಕೊಂದು ಜಾಯಿನ್ ಇದೆ. The radii of tube A, B, C are at the junction are respectively 2 centimeter, 1 centimeter, 2 centimeter. It can be said that, so ಇಲ್ಲಿ ನೋಡಿ ಮೂರು ಜಾಯಿನ್ ಆಗಿದೆ, ಹೌದಾ? ವಾಟರ್ ಲೆವೆಲ್ A, B ಮತ್ತೆ C ಅಲ್ಲಿ ಡಿಫರೆಂಟ್ ಆಗಿದೆ, right? The radius of that, whatever the junction you are seeing, the radius is given as 2 centimeter, 1 centimeter and 2 centimeter. So see, height of the liquid in the tube A is maximum. Height of the liquid in the tube A and B is the same. Height of the liquid in all the 3 tubes are same. Height of the liquid in the tubes A and C is same. So which option is correct here? Which one? A, B, C, D. Yes, very good. It is option D. The height of the liquid in the tube A and C is same, right? ಯಾಕಂತಂದ್ರೆ ನೋಡಿ ಅದರದ್ದು ರೇಡಿಯಸ್ ಕೂಡ ಸೇಮ್ ಇದೆ. ನೀವು ಫಿಗರ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ಅದರದ್ದು ಹೈಟ್ ಕೂಡ ನಮಗೆ ಸೇಮ್ ಆಗಿ ಕಾಣಿಸ್ತಾ ಇದೆ, ಆಯ್ತಾ? Then next question. It is option D. Okay. So the next question is, a manometer connected to a closed tap reads 3.5 into 10 raised to 5 Newton per meter square. When the valve is opened, the reading of manometer falls to 3 into 10 raised to 5 Newton per meter square. Then the velocity of the water is. So they are asking the velocity of the water. What we can do here, if you see the manometer, so it is used to measure the pressure here, right? So the equation of the manometer is given by, to calculate the speed, it is V square upon 2 plus P by rho is equal to, P by rho is equal to, that is constant. So now we'll in modbodu, idana now V1 square upon 2 plus P1 by rho, which is equal to same, that is whatever it is there, we will write this as constant and we will take the equation. So some students are getting the answer. Let's see, it is option B. Yes, it is option B. Option B is right here. So how to solve this one? You can take this equation, that is P by rho plus 1 by 2 V square is equal to constant. V square is equal to constant. So here the equation is simplified it as what? 1 by V square, 1 by 2 V square is equal to, that is P1 minus P2 divided by rho. Right? So you can substitute the value. P1 ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ. ಅದರದ್ದು pressure ಎಷ್ಟಿದೆ? 3.5 into 10 raised to 5. ಎಷ್ಟಕ್ಕೆ ಕಮ್ಮಿ ಆಗುತ್ತೆ? 3 into 10 raised to 5 ಅಂತ ಆಗುತ್ತೆ. Then next density of water is taken as 10 raised to 3. So simplify this equation and calculate it for V is equal to, you will get option B. Okay. Yes. Option B is the correct one here. So use this formula and simplify it. V is equal to, it is 10 meter per second. Next, last one more question we will see, then we will continue with the next topic. Last question. Air is streaming past a horizontal airplane wing such that its speed is 120 meter per second over the upper surface and 90 meter per second at the lower surface. So ಮೇಲ್ಗಡೆ, what is the speed? 120. ಕೆಳಗಡೆ, that is 90 meter per second for that air wing. Next, if the density of air is 1.3 kg per meter cube and the wing is 10 meter long and has an average width of 2 meter, then the difference of the pressure on the two sides of the wing is. So difference in the pressure they are asking. Right? So let us solve this one. So this can be simplified by using Bernoulli's principle. So Bernoulli's principle to application is there. Whatever the aeroplane is there, it works on the principle of Bernoulli's theorem. Right? So Bernoulli's equation in baratte, that is the potential pressure and the is equal to. So here it is P2 plus half rho V2 square. So what we require, see, the difference in the pressure we require, that is nothing but P2 minus P1 is equal to. So P2 minus P1 is equal to, substitute the values here. So if you substitute, P2 minus P1 is equal to, that is 1 by 2 into the density is given as 1.3. Density is given as 1.3 into bracket. So that is V1 and V2. V1 and V2 are how much? It is 120 and 90. Therefore, it is 120 square minus 90 square. So simplify this, you will get the difference in the pressure. You will get the difference in the pressure. Okay. So you can try this yourself. See, lane madbekagatte, this is in the form of a square minus b square. So a square minus b square, what is the formula? A plus b into a minus b. Aa tara simplify ಮಾಡಿ ಅಂದ್ರೆ ನಿಮಗೆ ಈಜಿ ಆಗುತ್ತೆ. Otherwise you need to take 120 square minus 90 square. So you can simplify it by using a plus b and a minus b. It is option A. Yes, correct. Very good. Right? Okay, students. So in the mechanical properties of fluids, we have discussed question on pressure. based on the Pascal's law, based on equation of continuity, based on the Bernoulli's principle. Okay, so based on these all concepts, we have covered the questions. So next we will go to the today's new topic, that is thermal properties of matter. So let us on the synopsis part. So thermal properties, first now synopsis and discuss madana, then we will go to the question answers. Yes, I hope the PPT is visible to you. So let us come to the formulas and the main points of this lesson. So thermal expansion. So what is the thermal properties of matter? Thermal properties of matter antandre ee topic alli now due to the heat what all changes are occurring that we are discussing. Aita. So here thermal expansion anta study ಮಾಡ್ತೀವಿ. So before that temperature scales, we know that we have degree Celsius scale, Fahrenheit scale and the Kelvin scale. Okay, so these are the three types of scale. Idanna bittu rumor matte Rankine anta kuda matte erad scale ide that we are not discussing in our syllabus. So we have only Celsius scale, Kelvin scale and the Fahrenheit scale. So illi first formula nodta idira. This formula is giving you the relation between, first one is the relation between Celsius and the Fahrenheit scale. So you can take down this so that if any question is there, we can use the formula. Aita, that is Tc is equal to 5 by 9 Tf minus 32 or Tf is equal to. Aita, so andre first formula ಏನು ನೋಡ್ತಾ ಇದ್ದೀರಾ, ಅವ್ರು ನಿಮ್ಗೆ ಏನಾದರೂ ಡಿಗ್ರಿ ಫ್ಯಾರನ್ಹೀಟ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ರೆ ನೀವು ಸೆಲ್ಸಿಯಸ್ ಅಲ್ಲಿ ಕನ್ವರ್ಟ್ ಮಾಡಬಹುದು. ಇಲ್ಲಿ ಸೆಕೆಂಡ್ ಫಾರ್ಮುಲಾ ನೋಡ್ತಾ ಇದ್ದೀರಾ, that is Tf is equal to 9 by 5 Tc plus 32. This is when it is given in Celsius conversion in terms of Fahrenheit. So next B, T is equal to Tc plus 273.15. This is Kelvin and Celsius relation. So Celsius ಅಲ್ಲಿ ಏನಾದರೂ 25 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಅಂತ ಅಂದ್ರೆ ಕೆಲ್ವಿನ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ plus 273.15 ಅಂತ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. So same way it is with the Celsius to Kelvin scale. Then next Fahrenheit to Kelvin, you can see the relation. It is 9 by 5 into T minus 459.67. Same way reverse of that. Okay, so this is regarding the temperature scales. Here last one point you discuss means it nodi temperature at which the Fahrenheit and the Celsius scales are showing the same reading. Yesterday gosatte minus 40 degree. So there is one temperature in Celsius and Fahrenheit scale. Both the temperature readings are showing the same, that is minus 40 degree. Minus 40 degree alli Celsius ಮತ್ತೆ Fahrenheit scale alli same reading anna ನಾವು ನೋಡಬಹುದು. ಆಯ್ತಾ? Then we have the thermal expansion. What is thermal expansion? If you consider any object, so ಇದಕ್ಕೆ heat ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ, it will start expanding. The object will start expanding here. So whatever the expansion you are seeing due to the heat, that is called as thermal expansion. We have three types of thermal expansion. Linear expansion ಅಂದ್ರೆ length ಹೆಚ್ಚಾಗುತ್ತೆ, aerial expansion ಅಂದ್ರೆ area ಹೆಚ್ಚಾಗುತ್ತೆ, volume expansion ಅಂದ್ರೆ volume ಹೆಚ್ಚಾಗುತ್ತೆ. ಆಯ್ತಾ? So here you can see the coefficient of linear expansion is denoted by the letter alpha. It is given by delta L by L is equal to alpha delta T. Delta T is the temperature difference, delta L is the change in length. Same way for a coefficient of aerial expansion, coefficient of volume expansion. Here we have the relation between alpha, beta, gamma. Alpha, beta, gamma is related with the ratio of 1:2:3. Right? Andre alpha value 1 iddaga the beta value will be twice of that anta ಹೇಳ್ತಾರೆ. Next. So this is thermal stress. What is thermal stress? Stress is nothing but force by area. So what is thermal stress? Due to the heat, the stress is occurring here, and that is given by Y alpha delta T. Y is called as Young's modulus. Howda? Alpha is coefficient of linear expansion. Delta T is the temperature difference. The specific heat capacity of a substance is defined as, so specific heat capacity S is equal to, it is 1/m delta Q by delta T, right? So delta Q is the heat, delta T is the temperature, m is the mass of the body, S is the specific heat. So if you consider iron, aluminium or any of the object, the specific heat capacity value will be constant. And you always remember water is having the highest specific heat capacity. Water specific heat capacity ಎಲ್ಲದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇದೆ ಆಯ್ತಾ. That is 4200 joules per kg per Kelvin. So we say that it has joules per kg per Kelvin 4200 ಅಂತಾನು ಹೇಳ್ತಾರೆ. ಕೆಲವೊಂದು ಬುಕ್ ಅಲ್ಲಿ they will give it as 4186 right. So then next, heat transfer. The heat can be transferred by three methods, that is conduction, convection and radiation. Conduction is what? Where the actual movement of the without movement of the particle the heat is getting transferred andre solids alli. With conduction, with the movement of the particle the heat is getting transferred is called as convection andre liquids alli. Then next, in case of gases we see radiation. Illenagatte medium enu movement agalla but heat is getting transferred here. So here we have one relation, you can see this, that is Q. The amount of heat is equal to area, temperature difference and time. It is inversely proportional to the length. Here K is called as constant. K ide idu constant ide aita. So what is this K? K is the coefficient of thermal conductivity. K is called as coefficient of thermal conductivity, right? So you can see this dt by dx, this is called as temperature gradient anta ಹೇಳ್ತಾರೆ. It is called as temperature gradient. Then Stephen's law. What is Stephen's law? This is given by E is equal to sigma T raised to 4. What is E here? This is the energy emitted. Energy emit ಆಗ್ತಾ ಇದೆ body ಇಂದ, that is directly proportional to the fourth power of the temperature. ಇಲ್ಲಿ sigma ಏನು ತಗೊಂತಾ ಇದ್ದೀರಾ, ಆ sigma ಏನಿದೆ constant ಇದೆ ಆಯ್ತಾ, it is constant. Then Newton's law of cooling is there. It is the rate of change of cooling is proportional to change in the temperature. So K is called as proportionality constant. Okay. Yes. So you can see this equation, if you want you can note down, because we are solving the questions based on this Newton's law of cooling. T1 ಮತ್ತೆ T2 temperature ಅಂತ ಆಗುತ್ತೆ. Okay. T0 is the room temperature, small t is the time, K is the constant here. Then Wien's displacement law. Wien's displacement law is given by lambda T is equal to constant. What is lambda? It is the maximum wavelength into temperature is constant. This is defined as Wien's displacement law. Then we have calorimetry. That calorimetry is nothing but it is the specific heat. Okay. So 1 calorie is equal to, new practical ಮಾಡಿರಬಹುದು first year ಅಲ್ಲಿ. So calorimetry new device ನೋಡಿದೀರಾ. That is heat lost by the hot body is equal to the heat gained by the cold body. What is 1 calorie? To increase the temperature by 1 degree Celsius, how much heat you require, that is called as 1 calorie. Okay. Then thermal capacity is given by mass into specific capacity, specific heat capacity. Then next we have latent heat of vaporization. So what is latent heat of vaporization? To change the state from, that is liquid to vapor state, that is called as what? Latent heat of vaporization. Yes. Then next, ಇದು principle of calorimetry. ನಾನು ಈಗಷ್ಟೇ ಹೇಳಿದೆ ನಿಮಗೆ, that is heat lost by hot body is equal to heat gained by cold body. So based on the questions, this convection already we have discussed. Radiation also we have discussed. Here we have emissive power. It is nothing but the radiant energy emitted per second is called as emissive power, denoted by the letter E. Then spectral emissive power is there, that is nothing but it is for the particular wavelength. Instead of all the wavelength, particular wavelength anna consider ಮಾಡ್ತೀವಿ ನಾವಿಲ್ಲಿ. Right. So you just go through the formula here. Relative permittivity is given by E by EB. Then perfectly black body, this is nothing but is one which completely absorb all the radiation, whatever the wavelength falls on it, that is called as perfectly black body. So the properties of perfectly black body are, see here, ಇದನ್ನ ಯಾಕೆ ನಾನು ಇಲ್ಲಿ ಸ್ಟ್ರೆಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, because we have the questions based on this. A perfectly black body absorbs all the radiations which is incidenting on it. A perfect black body does not reflect or transmit radiant heat incident upon it. Then the coefficient of emission of a perfect black body is very good emitter of heat. A perfect black body does not exist in the nature. Right? So nearly equal black bodies we will consider, that is of the order of 0.98%. Then Kirchhoff's law we don't have, so but if you require we can see the formula here. Okay, yes. So now let us go for the question answers. ಮತ್ತೆ ಅಲ್ಲಿ ಏನಾದರೂ ಆತರ ಬಂದ್ರೆ ನಾನು ಆವಾಗ ನಿಮಗೆ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ನಾವೀಗ ಏನು ಮಾಡೋಣ, ಕ್ವೆಶ್ಚನ್ಸ್ ಅನ್ನು ತಗೊಳ್ಳೋಣ, otherwise it is difficult to cover the questions. Yes. So I'll share the question. Yes. See students, the question is visible to you or no? Okay, I hope the PPT is visible to you. Let us start the question answers. Yes, so the first question is, absorptive power of perfectly black body is. So absorptive power anna nodidvi now, for perfectly black body they are asking. See, okay, so for perfectly black body, what is the answer? A, C, B, it is 0, infinity, 1 or constant? Yes, it is 1. Yes, very good students, it is 1. Okay, then the next question is, so the next question is, a black body at hot temperature, a black body at hot temperature at 227 degrees Celsius radiates heat at a rate of 5 calorie per centimeter square second at a temperature of 727 degrees Celsius. The rate of heat radiated per unit area will be. The rate of heat radiated per unit area will be. So how we are going to do this one? So see here. So the temperatures are given. T1, T2 temperature is given. The rate of heat is given. So they are asking the rate of heat radiated per unit area, right? So how to do this? The solution is according to Stefan-Boltzmann law. So according to Stefan-Boltzmann law, it is given by R1 by R2 is equal to T1 by T2 to the power of 4, to the power of 4, which is equal to, so R1 value is given, that is the heat rate is 5 divided by R2, which is equal to T1, T2. Celsius it is given in degree Celsius, convert it in terms of Kelvin. So it is plus 273. 227 plus 273, it will be, sorry, that is 500 divided by 727 plus 273, it will be 1000 to the power of 4, to the power of 4. Just to simplify it, for R2 is equal to ಎಷ್ಟು ಬರುತ್ತೆ? Calorie per centimeter. Yes, no need to convert, take it as it is, because ಕೊಟ್ಟಿರೋ ಡಾಟಾದಲ್ಲಿನೂ ಕ್ಯಾಲರಿನೇ ಇದೆ. ಸೊ ಆಪ್ಷನ್ಸ್ ಕೂಡ they are giving in the same, no need to convert, take it as it is. Option A, B, C, D. CAL per cm, that is calorie per centimeter square second. CAL is denoted for calorie. ಆಯ್ತಾ ಲೋಹಿತ್? ಕ್ಯಾಲರಿ ಹೀಟ್ ರೇಟ್ ಅನ್ನ ನಾವು ಕ್ಯಾಲರಿಯಲ್ಲೂ ಮೆಜರ್ ಮಾಡ್ತೀವಿ, ಜೂಲ್ಸ್ ಅಲ್ಲಿನೂ ಕೂಡ ಮೆಜರ್ ಮಾಡ್ತೀವಿ. ಕ್ಯಾಲರಿ ಇದು CGS ಯೂನಿಟ್ ಆಗುತ್ತೆ. Option A, B, C, D. Calculate students, I have given you the hint how to solve this. Calculate it for R2 is equal to So see here, here 2 zeros will go, here 2 zeros will go. It is 5 by 10 to the power of 4, that is equal to R2 is equal to. So nan again ಮಾಡ್ತೀನಿ, R2 is equal to. This is R2 is equal to 5 into 10 by 5 to the power of 4. ಏನ್ ಬರುತ್ತೆ? A, B, C, D. Yes, it is C. 80 ಬರುತ್ತೆ ನೋಡಿ, 80 calorie per centimeter square second. Simplify this, R2. Yes, very good. Let us go to the next question. Okay, a body cools from 50 degrees Celsius to 46 degrees Celsius in 5 minutes and to 40 degrees Celsius in next 10 minutes. The surrounding temperature is, they are asking the surrounding temperature. This you can calculate by using your which law? Newton's law. Newton's law of cooling anna use ಮಾಡಿ ನಾವಿಲ್ಲಿ calculate ಮಾಡಬಹುದಾಗಿದೆ. Okay. So it is nothing but d theta by dt is equal to, it is equal to minus k into bracket theta minus theta naught. So substitute the value d theta, change in the temperature. So I'll substitute it as, that is 50 minus 46 ಹೌದಾ, divided by time ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ, 5 ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. Therefore minus k into bracket the common temperature, that is here it is 50 minus t. This is my equation 1. This is my equation 1. So by next data calculate equation 2. So how we can calculate equation 2? That is 46 minus 40 divided by 10, which is equal to minus k into bracket 46 minus t and equation 2. Yes. So simplify equation 1 and 2. How we are going to simplify? Do it 1 divided by 2. 1 by 2 ಮಾಡ್ತೀರಾ? Equation 1 divided by equation 2. K cancel ಆಗುತ್ತೆ. T ಅನ್ನ simplify ಮಾಡಿ. Do it. Try and tell me what is the answer. A, B, C, D. What you are getting? Option A, exactly 30. Yes, check how much you are getting. Is it exactly 30? Okay. Yes, very good. Okay, so equation 1 by 2, you will get the answer A. Option A is the correct option here. Plus, we will go to the next question now. So the next question is, for which of the following process the thermal conduction is maximum? For which of the following process the thermal conduction is maximum? That is combustion, radiation, convection and conduction. So which one it is? Which one? A, B, C, D? Which one? It is B. Yes, for radiation. ಹೌದಾ? So radiation ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? The thermal conduction is maximum in case of radiation. It is maximum in case of radiation. Okay, let us go to the next question. That is a bucket full of water, hot water. Yeah, water, hot water anta ಕೊಟ್ಟಿದ್ದಾರೆ. Is kept. It is kept in a room and it cools from 75 degrees Celsius to 70 degrees Celsius in T1 minute. from 70 degrees Celsius to 65 degrees Celsius in T2 minute, and from 65 degrees Celsius to 60 degrees Celsius in T3 minute. Then, so which ratio is right? They are asking here. So again, it is based on the Newton's law. Option B. Okay, it is right. But let us see the solution here. So how we can do this? That is, so you can see this. So case 1 alli in formula en barutte nodi, d theta upon theta 2 minus theta 1 is equal to k dt. So case 1. So case 1 alli we will substitute the values. That is nothing but 75 minus 70. 75 minus 70 divided by theta 2. So theta 2 first navili tekkolana. So theta 2 is given by, it is 75 plus 70 divided by 2. So yes, 75 plus 70 divided by 2. This is nothing but 72.5. So theta 2 is how much? It is 72.5 minus theta 1 is equal to K, temperature is T1. This is case 1. So I'll simplify this for T1 is equal to T1 is equal to it is 5 divided by K into 72.5 minus theta 1. This is T1, right? This is T1. Similarly, do for case 2 and case 3. So, new simplify madi. Theta 2, I'll give you the hint here. So, theta 2 for this is case 1. Idu case 1 aitu. For case 2. So, for case 2, it is theta 2 is equal to 70 plus 65 by 2, which is equal to 67.5. Idu theta 2 agatte. So same. Illi yav tara substitute ಮಾಡಿದಿರಲ್ಲ ಆ ತರ ಅಲ್ಲಿ substitute ಮಾಡಿ. Okay. That is 70 minus 65. Illi d theta will be 70 minus 65. Case 3. Case 3 alli enagutte? In case of case 3, theta 2 will be 65 plus 60 by 2, which is equal to 62.5. Howda? So, ee ರೀತಿಯಾಗಿ ನೀವು solve ಮಾಡ್ತಾ ಹೋಗಿ. If you simplify according to case 1, the case 2, case 3 will be. So, ನಾನು ಇಲ್ಲಿ answer ಬರಿತಾ ಇದ್ದೀನಿ. ಯಾವ ತರ ಬರುತ್ತೆ ನೋಡಿ. Case 1, case 2, case 3. I just told you how you are going to take theta 2 value. Yes. So according to the solution, so in case of case 1, I just wrote there it is 5 divided by K into bracket, 5 divided by K into bracket 72.5 minus theta 1. This is case 1. Case 2 dalli en barutte ನೀವು simplify ಮಾಡಿದಾಗ it is 5 divided by 67.5 minus theta 1 into K. Case 3 alli en barutte T3 is equal to it is 5 divided by K into bracket 62.5 minus theta 1. So illi nodi 5 divided by K is common in all the 3 cases. Howda? So denominator the value ಹೆಚ್ಚಾದಾಗ numerator value ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಆಗುತ್ತೆ. Therefore in the given option C is the right one. That is T1 is less than T2 and which is less than your T3, right? So this is the proof. Option C is correct. Option C. Sorry, option B. Option B is correct here. Okay, T1 is less than T2, which is less than T3. Option B is the correct one. I hope the solution is clear to you. Yes, let us go to the next question. This theory, a good absorber of heat are, a good absorber of heat are non-emitter, poor emitter, good emitter, highly polished. A, B, C, D. Which one? Good absorber are always, yes, always it is a good emitter. They are always a good emitter. Option C is the correct one here. Okay. Seventh question. Two stars A and B radiate maximum energy at 3600 and 3600. Actually idu eradu 3600 anta idre namage 1 anta barutte alli option alli. So here what you do one thing, make a change here, that is one you take 3600 temperature and the other one you take it as 4800. This one you make it as 4800. 4800 respectively. Then the ratio of absolute temperature of A and B. So this is based on option C is correct. Option C is correct. So it is based on Main's displacement law. How we are going to do this? That is given by lambda is proportional to temperature. It is inversely proportional to temperature. That is lambda A by lambda B is equal to, it is TB divided by TA, which is equal to, okay, that is 3600 divided by 4800. So these two zeros will get cancelled. So this is 3 this is 4 that is 3:4. So the ratio of absolute temperature is 3:4. Option C. Option C is correct here. Okay. It is based on Main's displacement law. I hope this is clear to you. Let us go to the next question. A person with dark skin as compared to a person with white skin will experience less heat and less cold, more heat and more cold, more heat and less cold, less heat and more cold. A, B, C, D. It is option B. Yes. Because actually here what happens, because of the dark skin, the heat absorption will be more. Okay, the heat absorption will be more. So when the heat absorption will be more, obviously the more cold it is. Okay, so more heat, more cold. Option B is the right one here. Option B is correct one. Let us go to the next question. So that is, a cup of tea cools from 80 degrees Celsius to 60 degrees Celsius in 1 minute. Okay, this is based on Newton's law of cooling, right? The ambient temperature is 30 degrees Celsius. In cooling from 60 degrees Celsius to 50 degrees Celsius, it will take 50 seconds, 90 seconds, 60 seconds, and 30 seconds. In 1 minute, it is converting from 80 to 60. Howda? So 60 to 50 ಆಗಬೇಕಾದ್ರೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು. So few students are replying it as option A. Okay, so option A is right. Let's see the solution also. So how to do this? That is delta T, change in time, it is given by change in time upon time is equal to K into bracket T1 plus T2 divided by 2 minus T0. Aita? So change in time, it is 80 minus 60 divided by 60 is equal to K into bracket 80 plus 60 divided by 2 minus 30. Right? So if you simplify this, ಇಲ್ಲಿ ನೋಡಿ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಿದೆ, k ಮಾತ್ರ ಗೊತ್ತಿಲ್ಲ ನಮಗೆ. ನೀವು ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದ್ರೆ ನಿಮಗೆ k ಸಿಗುತ್ತೆ. The k value is, anybody got the k value here? So simplify. What is k value? If you simplify this, the k value is found to be 1 upon 120. Right? Similarly, after getting the k value, let us go when you are getting conversion from 60 to 50 degree. So it is 60 minus 50 divided by time is equal to, k value is how much? K value is 1 by 20. So it is 1 by 20 into bracket 60 plus 50 divided by 2 minus 30. ಹೌದಾ? So ಇಲ್ಲಿ ನಮಗೆ time t ಬೇಕಾಗುತ್ತೆ. So if you simplify this, t is equal to, you will get it as 50. Check out. You will get maybe 48, 49 something. So that is not there in the option. Directly we can take the nearby option, that is 50 seconds. 50 seconds. Right? So solve this. You will get option A is the answer. Okay. I'll go to the next question. Yes, the next question is, the best ideal black body is, which one? Lamp of charcoal heated, metal coated with a black dye, glass surface coated with coulter, hollow enclosure blackened inside and having a small hole. A, B, C, D, which one? It is, yes, option D. That is hollow enclosure blackened inside and having a small hole. That is a perfectly ideal black body. It is ideal black body. Then the next question is, the earth interrupts approximately 1 billionth of the power radiated by the sun. If the surface temperature of the sun were to drop by the factor of 2, the average radiant energy incident on earth per second would reduce by the factor of. So what they are saying, earth interrupts approximately 1 billionth of the power radiated by the sun. If the surface temperature of the sun were to drop by the factor of 2, the average radiant energy incident on earth per second. It is 2, 4, 8, 16. A, B, C, D. Which one is the option? What is the answer? 16. It is actually whatever the factor of the, that is temperature of the sun will drop by the factor of 2, whatever the radiation we are getting here, that will also reduce by the factor of 2. It is option A. It is option A. Aita? Then the next question. The process of heat transfer in which heat is transferred with actual migration of the medium particles is known as. What it is known as? Conduction, convection, radiation, Convection, yes. So in case of conduction, what happens? That is, particles are not moving. Convection, the particles are getting migrated here. Okay. Then the next question is, the unit of Stephen's constant is given by. What is the unit of Stephen's constant? Watt per meter per Kelvin square. Watt per meter square Kelvin square. Watt square per meter square Kelvin to the power of 4. Watt per meter Kelvin. A, B, C, D. It is B or it is C? B or C it is. Sure, yes. The unit of Stephen's constant. Stephen's constant ಅಂತಂದ್ರೆ sigma ಅಂತ ಬರುತ್ತೆ ಆಯ್ತಾ? Yes. It is T, K to the power 4 or K to the power 2? K to the power 4 ಬರುತ್ತಾ 2 ಬರುತ್ತಾ? See here, actually we will get it as K to the power 4, but K to the power 4 ಅಲ್ಲಿ ನಮಗೆ ಬರೀ ಆಪ್ಷನ್ ಸಿ ಮಾತ್ರ ಇದೆ, ಆದ್ರೆ ನಮಗೆ ಇಲ್ಲಿ ವ್ಯಾಟ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರಲ್ಲ. So watt square, and yes, it is K to the power 4. Therefore, here option B, but here whatever the K to the power is there, this should be 4. ಇದು 4 ಆದ್ರೆ ನಮಗೆ ನಾವು B ಅಂತ ಚೂಸ್ ಮಾಡಬಹುದು ಇಲ್ಲಿ ಆಯ್ತಾ. C ಮಾಡ್ಲಿಕ್ಕೆ ನಮಗೆ ಇಲ್ಲಿ ವ್ಯಾಟ್ ಸ್ಕ್ವೇರ್ ಅಂತ ಬರಲ್ಲ. ಒಂದೇ ನಾವು ಇಲ್ಲಿ C ಅಲ್ಲಿ ವ್ಯಾಟ್ ಸ್ಕ್ವೇರ್ ಅನ್ನ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಬೇಕು, ಅಥವಾ ಇಲ್ಲಿ K to the power 4 ಅಂತ ಮಾಡಬೇಕು. Right? So next question. Next is, a metal piece heated to T1 degree Kelvin. The temperature of the surrounding is T2 degree Kelvin. Yes, the heat in the surrounding due to the radiation is proportional to. Q is proportional to. Option A, that is T1 raised to 4. It is T1 raised to 4 minus T2 raised to 4. Option B is T1 minus T2 whole to the power 4. Power ಅಲ್ಲಿ ಇದೆ, ನೀವೇನ್ 4 ಮತ್ತೆ 3 ನೋಡ್ತಾ ಇದ್ದೀರಾ, that is in power. A, B, C, D. Q is proportional to. Yes, it is A. It is A. ಆಯ್ತಾ. So ಇದೇನು heat ಇದೆ ಅದು ಎದಕ್ಕೆ ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿರುತ್ತೆ? The heat is proportional to, it is to the power of 4. Means it is T1 minus T2. T1 raised to 4 minus T2 raised to 4. Heat is proportional to. Q is proportional to. Aita. So this is our answer. Option A is right option here. Okay. Then the last question for today's class. See this. The earth receives at its surface radiation from the sun at the rate of 1400 watt per meter square. The distance of the center of the sun from the surface of the earth is, distance is given as 1.5 to 10 raised to 11. 10 to the power 11 aita adu 10 to the power 11, and the radius is 7 into 10 to the power of 8. Treating sun as a black body, it follows from the above data that its surface temperature is. Its surface temperature they are asking. They are giving you the Q value. They are giving you the radius value. They are giving you the value of the surface area, right? The distance is given. Distance value is given. So let us see the solution and we will end the class. So see this, the solution is, it is given by the power radiated is equal to sigma A T to the power 4. So here sigma I'll keep as it is. area of the sphere, sun. So area of the sphere is given by 4 pi r square t to the power 4, right? Here the power per unit area. So the power per unit area ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ? So this is sigma 4 pi r square t raised to 4 divided by, it is 4 pi d square. It is 4 pi d square, and this value they have given it as 1400. It is given it as 1400. ಆಯ್ತಾ? ನಮಗೆ t to the power 4 ಬೇಕಾಗಿದೆ. So if you simplify this, t to the power 4 is equal to 1400 into d square divided by, it is sigma r square. Okay, so if I substitute the value here, that is 1400 into d square is 1.5 into 10 to the power, it is into 10 to the power 11 whole square divided by sigma value is constant, it is 5.6 into 10 raised to minus 8 into r square. R square is how much? It is 7 into 10 raised to 8 whole square. So take down this and calculate t is equal to. You may simplify madidanna. So t is equal to, check, you should get the answer A. Option A baratte. Idu note madkoli solution anna. Later you simplify it for t is equal to. Okay. Option A will come. Yes, very good. Option A will come. So next class we are discussing kinetic theory. Next class, Lohit. Next class we will be discussing kinetic theory of gases. Okay. Take down the solution, solve it by yourself. We will continue in the next class. Thank you, students.